Find the average value of f of x equal to 35x to the 2.3 power times e to the negative 0.37x for x from 3 to 15. Use your calculator. Okay, that's a good thing we get to use our calculator because this is a product. We don't have any integration rules for product. And in fact, there isn't an easy substitution. This one might be doable by integration by parts, but I'm going to follow the hint and use the calculator. So we need to know what average value is, and I'm going to review that momentarily. Average value of a continuous valued function f of x on a to b is equal to 1 over b minus a times the integral from a to b of f of x dx. So it's the area under the curve. Integral of a to b of f of x dx is the area under the curve between a and b divided by the length you've integrated along. And that makes sense. You've got an area, you're dividing by a dimension this way, you're going to get a dimension this way. For a rectangle, that would be the height of the rectangle. And since this is going to have some form to it, that will be the average height over that distance. So all we need to do is integrate from 3 to 15 of our function, 35x to the 2.3 e to the negative 0.37x dx. And that's not it. We have to divide by 1 over 15 minus 3, which is 1/12. So it's going to be 1/12 what we get for the integral. Now, for expediency's sake, I've typed in the integral. And let's have a look at it. I'm going to pick a window from 0 to, well, 15 makes sense, I guess. Maybe we'll go 20 and look a little further. I'm going to go zoom 0, let the calculator figure out the y dimensions. We'll get a graph of what we're looking at. That's something that goes up for a while, and then it comes back down. And we're asked to find the average value from 3 to 15. So all I need to do is use the integration estimator on the calculator, which is number 7. Choose the correct lower limit of 3, upper limit of 15. It's going to shade in the area it's found, which is quite handy. So the area here is 2042.24. So that's the integral part. So 1/12 of 2042.2481. This is an approximation, but it's good enough for, that's the only thing we're going to get out of this anyway. And if you think about it, you're finding basically the height of a rectangle that would have the exact same area as this thing. So this rectangle here maybe would work. So I write all over my calculator. And that height, if you take the area, divide by the width, you get the length or height, whichever way you want to do it. So that height we just found is the average height. So there's your answer. You can do that arithmetic and finish the problem.